think you can admit him too, Lydia. Give it a try next time.
Okay, I think I just submitted too.
And you can record too, I believe.
Okay. I think, yeah, I'm recording right now.
If you want to turn on your cameras, it'll help me, I think. We got 17, 18, 19. All right, I put up a new homework a few minutes before the class, and it's more with Z transforms, inverse Z transforms, and the frequency response, and then really it's asking a whole bunch of questions that deal with either inverse Z transform difference equations or frequency response. How many we have now? 20?
Mm-hmm. Yep,
Okay.
20.
All right. I guess the first order of business is everybody should have got their grades. I sent them out to everybody.
I got mine.
All right. And the second thing, if you can turn on your cameras, please do so. It'll make it easier for me to get an idea what's going on. I've noticed that in my other class, people are growing beards in general. They're not worrying about any, I don't even know there's such thing as a dress code for an undergraduate, but anyway, their appearance is as casual as they can get. And I don't care about that because I think most professors are that way too. There's no reason to dress up because you're not interfacing with the public, you're interfacing with your class. Okay, we got 20, right? Lydia, if anybody else comes in, my attention is going to be elsewhere. Please admit them.
Okay.
Now, first, any questions about what we've covered so far at all? I'll give you some homework. Anything at all?
I had a question about this is gonna be kind of hard to explain, I guess, but like, so when we do the inverse Z transform, we sometimes we get like a U function, right? And that would give
U of n.
Right, U of n. But that U of n, let's say it's one U of n, just U of n, right?
Mm-hmm.
That would essentially add 1 to every n, right?
I'm not sure I understand this. I'm going to try to cast this. First, I'm going to try to get my camera. Give me 1 second. Hang on for 1 second. All right, hold on. I have to cast this, and I hope it casts. There it goes. I have to share screen. You should see a yellow tablet.
Mm-hmm.
What you're saying is that, and what I'm asking is this, because to understand your question. If I have U of n, that gives me a Z transform of Z over Z minus 1. Now, if you're asking what U of n looks like versus n, at 0, it becomes 1. At 1, it's 1. At 2, it's 1, and so forth, all the way down. Right?
Correct. Okay, so I guess my question was like, let's say the Z transformation broke into parts and you were able to get U of n plus the quantity of like 1/2 plus 1. Being
1/2 plus 1?
Yes. Or sorry, comma 1. Sorry, comma 1.
1/2, comma 1. 2 points. And is this going to be at 0?
Yes, that's a 0.
All right.
So that would essentially just add 1 to those.
Well, what are
components,
these
right?
in terms? This is what, 1/2 delta of n, right? Plus delta of n minus 1, right?
Right.
So if you just do it, if you want the actual values, I mean, this is a mathematical function. U of n plus these is the identical, it's an exact function, right?
Okay, yeah.
All right, now if you wanted the values, when n is equal to 0, it's 3/2. So if you put 0, it would be 3/2. At 1, when it's 1, you have 1, and then you have 1 here, so it would be 2, right?
Yes,
And then at 2, what would it be?
just 1.
Right, it would be 1 from there on out.
Okay,
Yeah.
great. Thanks.
That's it. Other questions? There are no dumb questions, just people that are at times a little hesitant to share their thoughts, but they shouldn't be at this point. This is for everybody's benefit. Anything else? You know, I can't see, I don't know who, I can see only, let me see if I can see more people. Lydia, is anybody waiting to get in?
No one.
Okay. We have 20 now,
20 students.
and I encourage you to turn on your screens. I'm trying to pull this out here so I can see. I've got 1, 2, 3, 4, 5 people with their screens on. I'm telling you, it's much easier for me to get a read on people, but if people are for whatever reason, maybe they're watching TV or talking to their friends, they don't want to, I understand that, but it helps me. Now, any other questions before I get going with what I had planned today? From anyone? All right, everybody got their grades. The homeworks are up there with solutions. I'm trying to make it as clear as possible what I'm expecting of you to do. And if you do the homework without looking at the solutions, it'll benefit you more, because then what you'll do is you'll form questions in your mind. You don't understand this point, and you'll think about it. And if you can't get you can't come to terms with it yourself, then you look at the solutions, and then it'll stay with you. Trust me, if you just look at the solutions as you read it, it's not going to mean much to you. You will forget a lot of that. That's a trick. I don't know if I remember exactly where that was, but I think it was in my psych class when I was an undergrad. I got that, and I was thankful. I'm trying to do one thing here, but it's not exactly doing what I want. That's better, I think. All right, so today what I had planned is this. I was going to do a couple of the problems, or at least talk about it. This is from the last problem set was 25, right?
Yeah.
Everybody? And with problem 17.7, I believe I did A and I did D. Is that correct? Or not? Do y'all remember me doing it or not?
You did 17.15. You did 17.16. I don't think you did 17.17
Then we're going to do it right now.
or 7.17.
All right, we're going to do it right now. Now, this is about the inverse Z transform. I put up some notes and I said, there's 2 ways to do this. Usually the best way to do the Z transform of a function, if you have X of Z, is to first divide by Z and then do the partial fraction expansion.
Are you intentionally keeping us still on the OneNote, or are you wanting to show us the?
I'm intentionally making another mistake. I didn't shut that down. I meant to shut that down. So normally if you have X of Z, you divide by Z. Did you look at the notes on this one? People, do y'all remember seeing that? I had that, I discussed this in the actual homework about how to do it. This is normal. Sometimes you don't have to do it. So if you start with 17, you got your books there, 7.17 part A. This is 7. Lydia, are you recording this too?
Yes.
Okay. 7.17a, it says this, and please ask yourself, how would you do it right now without anything more? If you have X of Z equal to Z plus 1 over 2Z. How are you going to do that one? Don't answer it quite yet. Just think about it. Well, this is so simple, you don't even have to do anything. If I go ahead and just break this up, well, if I have Z over 2Z, it's 1/2, right?
Mm-hmm.
And then I have plus 1 over 2z, right?
Yes.
All right. Now, question, what does delta of n go to?
1.
In the z domain, correct?
Mm-hmm.
If it had 1/2 out in front of it, what would it go to over here?
1/2.
All right, so I can see that this in the z domain would transform as 1/2 delta of n into the n domain. You all follow me on this?
Mm-hmm.
This is so simple, we don't need to do any kind of formal pole expansion. Now, what about this? I'm going to ask you a question. What does delta of n minus 1 transform as?
Z to the -1.
Simply 1 over z, correct? Isn't that right, class?
Yes.
Come with me? That's simply this function. Delta of n goes to 1. Therefore, delta of n minus 1 would be 1 over z to the -1, right? Delta of n minus 2 would be 1 over z to the minus, or z, 1 over z squared, correct, class?
Mm-hmm.
All right, now I know that. What if there's a 1/2 here
1 over 2z.
on top, right? Agreed? 1/2 or 1 over 2z. So this one's almost, what it really does is if you understand z transforms, this is almost an insult to your intelligence. It's like, why would you even ask us that? It's too simple, but it's a good place to start. So that's 1/2, right? Right here, delta of n minus 1. Does everybody see? Out of kick,
Yes.
what if I put 1/8 z squared? Now what?
Would
If
it be 1/8 delta of n minus 2?
You would add on 1/8 delta of n minus 2. Do y'all see this, class?
Mm-hmm.
You see the logic in what I'm doing? Everybody?
Yeah.
People?
Yep. Yeah.
All right, that's, so when it's that simple, you don't need to do anything fancy. Just go right at it because it's a see-through problem. Now, I'm going to do going to do part D. And this is, again, an inverse Z transform. This time, it pays to divide by Z. Please work this with me. I want you to, if you got a piece of paper here and a pen, just work it with me. Don't look at the solutions. Just go down here and try it. So for this one, I have, this is part D. I have x of Z, I'm just recopying, equals Z squared plus 3Z. And it's over Z squared plus 3Z plus 2. I knew it. Give me 1 second. Hello? Goodbye. Anyway, for this thing right here, what I'm
Dr.
going
Baginski,
yes,
in the denominator, is that a z squared plus 3z?
yeah, plus 3Z. It's the problem. Just, do you have your book? Whoever asked that?
I do not currently. It's in the other room. I'll go grab it now.
If you got your book, it's just, I can just reference something in your book and it makes it easier for me, but I'm trying to be clear about this. Now you all see that, right? Now this one, you'll notice the order of the denominator is the same as the order of the numerator, right? The highest power, correct? There's
Yes.
two ways to do this. One is you could take the denominator and divide it into the numerator. Then you would get a single value plus a remainder, and the remainder would be another fractional form, all right? Now that's one way. The second way, that's probably in general the easiest, is divide by z. So if you divide by z, you get x of z over z. This is what we're going to expand. Now I have z plus 3, right, over, and what is this factor to? Z squared plus 3z is what? Z plus 1, right? Z plus 2. Do you agree?
Mm-hmm.
Got to make sure you all see this, guys.
Mm-hmm.
You there, Jacob? Matthew? Okay, all right. Appreciate your cameras too. Everybody, right? Now that if you have that, this I'm going to do a pole zero or pole expansion of. So I have z plus 3, z plus 1, z plus 2, and I expand it. And here I'm going to have some a over z plus 1 plus b over z plus 2, correct?
Mhm.
All right, now solve.
I have a question, Dr. Baginski. When you divided by z,
Mhm.
is there supposed to be a z on the right side as well, or no?
When I divided by z, the power here is dropped by 1. So
Okay,
z
so-
squared becomes z
okay.
and 3z becomes 3.
That makes sense. Thank you.
Right? Yeah, remember this is x of z over z. Now, to find a, what do? I cover that up and let z become what?
-1.
What is it? Minus 1 plus 3 is 2, right? Minus 1 plus 2 is 1. So it's what? 2, isn't it? You all see what I'm doing, class? All right, what's the next one, someone? All right, I cover this up and I let z equal to minus 2, right? On top, it's 1. On the bottom, it's minus 1s. Do you agree with that?
Yeah. Right.
Everybody? Hmm?
Mhm.
Okay. Any thumbs up or down? Y'all good with that?
Mhm.
All right. Now, if I have that, remember that's x of z over z, right?
Mhm.
Now I multiply by z. Y'all see that? Now when you multiply by z and do the inverse, what do you get? This is going to be x of z here. We've done the partial fractions, right? We've got a partial fraction expansion. Do you all agree? But we divided by z first. That's the key thing. Now, after that, we're going to go back. And remember, you have to understand the basic z transform pairings. You have to understand u of n goes to z over z minus 1. A to the n u of n goes to z over z minus a. And really, delta n goes to 1, stuff like that. The very basic formula or basic transform pairings you have to understand. Then you have to understand the properties of modulation, right? And if you have two functions that are convolved in the n domain, they're multiplied in the z domain, things of that nature. Those are properties, right? You have to understand the properties. Now, when we do this, what does this one go to? Well, its coefficient 2 just translates. This is going to be x of n, right? Yeah, are you with me? What about
Yeah.
this? This is z over z minus a, but what's a? Minus 1, isn't it, class?
Mhm.
Take a look.
Mhm.
So this is going to be minus 1 to the n, u of n. What about this one? Minus what?
Yep.
Minus 2 to the n, u of n, right? Take a moment, convince yourself, right? The reason is that it's minus is because this is usually minus a, right? But this is now minus a minus 1, correct, class? Okay?
Yep.
Y'all say it, everyone?
Yep.
Yeah.
Now, what is x of 0? All right, what is minus 1 to the 0 is?
1.
1.
When u of n, u of 0 is 1. So this is 2, the first part, minus what's minus 2 to the n is 1, right?
Mhm.
Hey, somebody needs to get in, Lydia.
Okay.
A minute. And so this is going to be minus 1 or it's 1. Do you follow me?
Mhm.
Mhm.
Now what we could have done, and that's the correct answer, and that's the way I would do this problem. What we could have done is this. I'm going to take the original equation and I'm going to divide the denominator into the numerator. So, and if I do that, I have z squared plus 3z divided by z cubed plus 3z plus 2. And that's z squared, pardon. Z squared goes into z squared 1, right? So then I put down, I recopy this, which would be z squared plus 3z plus 2. And then I subtract the bottom from the top, correct, class? This is just division. When I do this, I get 0 plus 0 minus 2, correct?
Mhm.
That means now that equation would be 1 minus 2 over z squared plus 3z plus 2, but I'll break it down. Z plus 1, z plus 2. Do you all follow me what I've done here?
Mhm.
The 1 comes from there, right? And the remainder is minus 2, and that would be divided by this. And this is x of z as well, correct?
Mhm.
Yeah.
I'm showing you an alternative method. It's going to give us a different form of the solution, but mathematically it gives the exact same values for every value of n. I'm trying to show you some of the things that happen with z transforms. Now, when I look at this,
For what?
the minus 2 over z plus 1,
Mount? Mm-hmm.
z plus 2 is going to be sum a over z plus 1 plus b over z plus 2, correct?
Yeah.
And how do you get a?
It's just
What do
a
we do?
cover-up method again, right?
Yeah, and let z become what?
Negative 1.
Minus 1 plus 2 is 1, right? So minus 2 over 1 is minus 2 over z plus 1. Want to hazard a guess what b is?
2.
Probably plus 2. Let's see. If I cover this up, right? Cover that up right there. And then let z be equal to minus 2. I have minus 2 over minus 2 plus 1, which is minus 1, is simply 2 over z plus 2, correct?
Mm-hmm.
Mm-hmm.
All right, now I need the inverse z transform of this. I'm going to try to fit it here. I have 1 minus 2 over z plus 1 plus 2. Matter of fact, let me write this on with another sheet of paper just because I'm going to try to shoehorn it here. And I'll slide it down in 1 second. So this is really equal to 1 minus 2 over z plus 1, right, plus 2 over z plus 2. And that's my x of z, correct?
Yes.
Mm-hmm.
Y'all agree with that, guys?
Mm-hmm.
Why would the
Mhm.
negative not distribute?
Yeah, that's what I thought too.
Why would
Because
what?
the
This is
negative was
negative
already
2.
in the negative was in the partial fraction expansion already.
It's right there.
Oh, okay. It just got carried over. Thank you.
Y'all see this?
Okay, I see.
Mm-hmm.
So that's what it goes to. Do you all agree with that? And that's a 2. Right? All right.
Yep.
Now, to go back the other way, what does 1 go to?
Delta of t.
And delta
Oh,
of n.
and yeah.
I'm a stickler. When I see a t there, it's like, what are you thinking? I know those kind of things you can trip over, but don't do it on an exam. All right. What about the next one? This is the one that gets people. You know, the minus 2 just carries, right?
Yeah.
So let me ask you this. If I had minus 1 to the n u of n, what does that go to? Z over z plus 1, right?
Yes.
All right. Now, what if I had minus 1 to the n minus 1, u of n minus 1? It would be this divided by z, correct? I literally took this function. If you call this my, say, y of n, and now y of n minus 1. Well, you know what I end up doing is dividing this by z, or that simply goes to 1 over z plus 1. Right? And my point is this. Whenever you say, there should be a z up there, but there's not. That's simply going to be the transform of z over z plus 1 delayed by 1. So I know that z over z plus 1 is minus 1 of n u of n because it doesn't have a z on top here, and it should. I know it's been divided by z of sorts, correct? So now I just make this minus 1 n minus 1 u of n minus 1. You all follow me with what I did there? I used the delay property. Now what about the next one? This is feeling pretty good. You're going to get plus what?
2 times
So?
negative
Negative
2
2 to the n minus 1.
Times u of.
n minus 1.
Very good. And that's important. Now you see that there's a little more complexity in that method's solution than the original one. But if you look in the book, I believe in the solutions, I believe this is what he has. Can anybody check that on for me?
It is.
Now this is more complicated in my opinion. It's easier to do it by dividing by z.
Could you, that dividing by z method, could you do that with Laplace, or is there something special about
You're talking about dividing by s, don't you mean that?
Yeah, dividing by s.
We can, and we do that, by the way.
Okay.
If you look at the Laplace properties, remember, I'm gonna, all the properties of Z transforms have a parallel with Laplace.
Okay.
And, but really what Laplace is, if we had something where we had numerator and denominator of same power of S, we would always do division. We take the denominator, divide it into the numerator, we get a value plus a remainder. And those problems in Laplace are easier to do it that way.
Okay.
In Z transform, in my opinion, it's easier to divide by Z because there were only two poles that we had to solve for.
Mhm.
Here, we had to actually know a shift operator, and technically we had 3 terms to go from the Z domain back to the N domain. Correct, class?
Mhm.
Okay. Are you good with this, everyone?
Yep.
Next, what about, let's see here. Well, how would you guys do B? There's a lot of ways. So this is 717B. I have Z minus 1 over Z minus 2. Now ask yourself, think of it as a test question or quiz. How would you do that? Well, there's several ways. All right, you could divide the denominator into the numerator. You surely could do that. You could break it apart, can't you? You can say that's just Z over Z minus 2 minus 1 over Z minus 2. Let's try this approach. So I want to go back into I want to find if this is X of N. I want to get X of Z, pardon me, X of Z. How do I get X of N? Anyone? Tell me about this one. How does this go back? Anyone?
That would that
That's
be
negative 2
That's your, yeah,
to
just
the
your
n.
transform.
2 to
Z
the
times
over
n.
Z minus A.
It would be just 2 to the n U of N. Do you agree with me there?
Mhm.
Yeah.
Take a look. Guys, are you getting this or not?
Mhm.
Denai, are you there? Jacob? I'm just looking for a thumb or a picture or something. I got Matthews there. Denai? Jacob? Oh, you're there.
Oh, okay. I see.
I'm just trying to make sure that I'm getting through to you. And there's nothing tricky about this. Now, what about the next one? Minus what? Anybody want to try it? Well, ask yourself, what if there was Z over Z minus 2? If it was Z over Z minus 2, it would be this, right?
Right.
But this is really what? Z over Z minus 2 times 1 over Z, isn't it?
Yes.
Yeah.
So that's a delay by 1. So that's just 2 to the n minus 1, U of n minus 1. Do you agree with me?
Mhm.
Yeah.
That's pretty straightforward, in my opinion. I'm trying to focus on the simplicity of this. If you're familiar with the properties, and delay is a property, the delay operator. All right, let's try another one. How about C? Let's try this one. Now here we have 2z, right? Plus 3 over z squared times z plus 1. What is this going to be? Do we need to divide by z? Not really, right? Numerator has an order less than the denominator, correct?
Mhm.
All right, but what do we have to do? We have poles here. We have a double pole, so we have a over z, right? Plus b over z squared, correct? Right, isn't that z squared there? And
Yeah.
plus some c over z plus 1. Okay, now, I don't know how the book does it. I probably should flip it over, or I mean, show you the solutions. I haven't done this one, but how would you get, say, c? Let's try the one that's most obvious.
You would cover up z
Cover up
plus
again, right?
1 and then make z equal to -1.
And what is it going to be?
One.
All right, if it's -1, 2, -1 is -2 plus 3 is 1, right? And
Mhm.
-1 squared is 1, so it's really 1 over z plus 1, correct? Guys?
Yeah.
It should just be 1.
Yeah, I thought it was 1 because the other z plus 1 goes away. Wait.
Yeah, you're
If you-
covering the z plus 1.
Yeah, and
If
then
you
you
cover
just
this-
get z squared, which would be 1 over 1.
I believe there's just like a little bit of a miscommunication. I think he's saying c is equal to
I mean,
1,
I'm
and then he's
trying
just
to-
plugging c back
Oh.
in.
This is c.
Oh.
Okay,
I've
okay.
taken the last one first, I'm sorry. So if you cover up z plus 1,
Can we
'cause
move the
that's,
paper up?
Yeah.
Thank you.
sure, if you cover up z plus 1 right there, you get the idea like that right here, right? You cover that up. Then let z be equal to -1. You get -2 plus 3 is just 1. -1 squared is 1. It's 1 over z plus 1, right?
Yep.
Now the next part you get is the z squared. All right. That means you cover the z squared up, right?
Mhm.
And you let z equal 0, right?
Mhm.
Mhm.
And that's 3, right?
Yep.
Now to get this one, what you would normally do is multiply by z squared and then take a derivative with respect to z and set it, and then basically you would set it equal to a, but you would have to evaluate the pole at z equals 0. Or you could do one thing, and what would that be? Remember, we have b and c. So what we have is this. We have a over z plus 3 over z squared plus 1 over z plus 1, correct?
Right.
And we know that this is equal to 2z plus 3 over z squared, z plus 1. Now, I do this because most students, I found out, tend to like this method better. Now, if we get a common denominator here, we would have what? We would have z squared over z plus 1. It would be the same as this. Then for a, my coefficient would be a times z, right? Times z plus 1, correct?
Dr. Baginski, could you move the page up a little bit?
Yes.
Thank you.
Yes. All right. Does everybody agree with that? I'm going to, I don't know what a is, but I'm putting it under, so it's going to have a z because it's divided by z and the z squared is down here. Then z plus 1 plus 3 times z plus 1, right? And then plus what? Just z squared, right? You guys with me?
Yep.
Y'all follow me? I'm just doing one. I'm getting all these things under a common denominator. A is the only thing I don't know. I'm not doing it with the derivative method this time. So now what am I equating? I have 2z on this side plus 3 equal to, and on this side, I'm going to get the highest power of z, which is z squared. And if I look at this, I have what? Az squared, right? Right? That's z times z is z squared. And then I have plus z squared, right? And over here, what do I have? I have 0 z squared, right? There are no z squared terms over there. Correct, class?
Correct.
Y'all see this?
Yes.
The coefficient of z squared is 0. So that means a plus 1 equals 0, or a is equal to minus 1. Minus 1. Correct, class?
Mm-hmm.
Now, bear with me. I have that. And this is one way, not the only way. So now I have my x of z equal to minus 1 over z plus 3 over z squared plus 1 over z plus 1. Agreed?
Mm-hmm.
Mm-hmm.
And
Yep.
now I'm going to go through this probably for the last time to show the way you get x of n. I'm going to do it with more information than usual. I'm literally going to show you the relationship. So if I have delta of n, that goes to 1.
Mm-hmm.
If I have delta of n minus 1, that goes to 1 over z.
Mm-hmm.
If I have minus delta of n minus 1, it goes to minus 1 over z.
Mm-hmm.
Agreed.
Mm-hmm.
I'm doing it this way for a reason. This should make it clear, my thought process and why it's true. That means x, this term simply goes to minus delta of n minus 1. Are we good on that?
Yep.
Yep.
Next, if I have delta of n goes to 1, then 3 delta of n goes to 3.
Mm-hmm.
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 And 3 delta of n minus 2 goes to 3 over z squared. Do you agree with me?
Yes.
Yep.
All right. Therefore, that term is 3 times delta of n minus 2, correct?
Yep.
Yes.
Yep.
All right. What about this last term? Somebody do this for me. What is your thoughts on it?
It looks like it should have a Z in the top, but it doesn't. So
Stop right there. Stop there. What if we had z over z plus 1? What does that go to in the n domain?
U of
1
n.
to the n u of n. Or
Minus
u of n.
1.
Negative 1 to the
Minus 1 to the n u of n. Remember, minus 1, right?
Mm-hmm.
That's not a small mistake either. This is a high frequency signal. Just u of n times 1 to the n is a low frequency signal. It's basically almost DC. Just remember that. This is something that's oscillating continually. Now, keep going.
And then
Therefore,
because it's
if-
there's not a Z.
if I divide by z, then it's n minus 1, right?
Mm-hmm.
All right. Okay, everyone?
Yep.
So this is going to be plus minus 1 to the n minus 1 u of n minus 1. Remember, it's just not minus 1 to the n u of n minus 1. It's minus 1 to the n minus 1 u of n minus 1, correct?
Mm-hmm.
Yes.
I've got a question. So what is x of 0? Is this on yet?
No.
Is this on yet?
No.
Is this on yet?
No.
0. Follow me?
Mm-hmm.
Yep. And you can go through this if I ask for a specific value. Give me 1 second. I got a bunch of things that I shouldn't have. All right, never mind. Okay. Are we clear on that stuff?
Mm-hmm.
Let's do another, because this is the things that's important. Hey, can you check in the book if they have this form of the answer, if they have something else? I mean, check in the solutions I've given you, someone?
Yeah, give me a second.
You could have several different forms of this answer. And I'll tell you why. You see how you have a u of n minus 1, and this is at n minus 1 here? You can combine, you literally create a single function to do that. You don't have to. There's different ways to derive a function. Will have the same exact values for all values of n.
Dr. Baginski, quick question. So if you have like a z squared over a z plus 1, would that be n minus 2?
Hold it.
U of n minus 2?
X of z equals, you say z squared over what?
Z plus 1?
All right, now that's z squared, right? That's not divided by z, is it? I mean, it's not.
Yes.
All right, that is something that would be a plus 1, correct?
Can you scoot it down?
Yeah. Here, I'll show you in the properties. That way it'll be clear.
In the solutions that you gave us, they use the convolution property. So they broke it into multiplicative components and then just found the inverse of those components and then convoluted them all together.
Involve them.
Yes.
That's, I think, a little more work.
Yeah.
This is, to me, it's obvious this way. And you can check for their values of n equals 0. It should give a value of 0.
Yeah, it looks pretty like similar.
It'll be the same exact values for all values of n. I like this way easier. It's easier for me. Why we're on this, let me go ahead and say that the inverse z transforms are beneficial when you're going to solve a difference equation with an input-output x of z going in, and you want y of, and you want to know what y of z is. Solving difference equations, this is powerful. Now remember, when you had differential equations, the most powerful technique to solve them was Laplace transform, right? If you had a differential equation, you solve the differential equation in the S domain, and you got a y of s, then you use partial fractions to get the actual y of t, right?
Mhm.
That was the easiest possible way to do it. With difference equations, you solve the difference equations by taking the z transform, and then after you find that, do the inverse z transform to find the actual solution, the value of y of n. All right, that's the way you do it. I'm going to solve a difference equation for a base. This is going to be, I want to show you this. If we go to 719, I'm going to simply do this. I'm going to get rid of the initial conditions because this will take too long, but I want to show you how to solve a difference equation. So this is 719. And if we have this, I'm going to use this difference equation, y of n minus 5 times y of n minus 1 plus 6 times y of n minus 2 is equal to 4u of n. Now, usually on this side, it's x of n. But he's not even going to put an x of n in there. He's just going to state what it is. It's u of n, 4u of n, all right? Are we good on this?
Mm-hmm.
Now, let's assume no initial conditions. We can do the initial conditions in a second, but I want to show you how to solve this with no initial conditions. All right, I want a solution. I want to know what y of n is. All right. The one way to do it is this. You could do it recursively. You could say y of n on this side and take this term and this term to the other side, start at n equals 0, get a value, and then you would get a value on this side, y of n minus 1, y of n minus 2 would be 0. There's no initial conditions, I'm saying. And what you would end up doing is saying y of n would be 4 times u of 0, which is equal to 1, and y of 0 would be 4. Then, now you have a value at 0. Now you increase n to 1, and you'd say y of 1 would be equal to 4 plus y of 0, plus 5 times y of 0, which was 4, or 20, plus, and this would be 0. So it would be 4 plus 20, or 24. You could do it that way. Do you follow me? Recursively.
Mm-hmm.
That's a pain. A computer can do it very quickly, but going through it longhand is a pain. So we take this.
Dr. Baginski, the only way you can do it that way is if they give you the 4u of n on that side. If they would have just given you x of n, you have to use a difference equation, correct?
And by the way, if they just gave you x of n, we could not solve it for for a specific y of n. We would solve the transfer function. We'd solve the ratio of y to x.
Okay.
Follow me?
hmm
All right, but for now, let me go through this. Let's take the Z transform of both sides. So I have Y of Z here. Y of N goes to Y of Z, right? Y'all see it?
Yep.
All right, Y of N goes to Y of Z. Just put a bracket, a parenthesis there. That means it has a coefficient of 1. Now, minus 5 of Y of N minus 1 is what? Minus 5 Y of Z over Z, correct?
Yes.
So I'm left with just minus 5 over Z, because what I'm trying to say is Y of N minus 1 would go to simply Y of Z over Z if there were no initial conditions. Now, if there were initial conditions, you would say plus Y of minus 1, right?
hmm
Got me on that, guys? Brandon,
Yeah.
can you see this okay or not? You can?
Yeah, I got it.
I'm not getting a real good read on the whole class. I'm getting a good read on the people with their cameras. But overall, y'all see this?
Yes.
Yeah.
Yeah. Okay. All right. I'm following.
All right. What's the next one? Plus what?
6.
6
over
over
Z
Z
squared.
squared.
Right. Equal?
Equal to
4 times Z over Z minus 1.
Right. You with me, everybody?
Mhm.
Guys?
Yep.
William?
Yep.
I mean, can you all see it?
hmm
Sir.
Now, remember, I got Z 1 over Z squared here. Do I want that?
No.
I want to multiply everything by Z squared. All right. So, and then I want to divide by this. So I'm going to get Y of Z equal to, just follow me. I'm going to have 4Z over Z minus 1. Now I'm going to multiply both sides first by Z squared. So I'm going to multiply this by Z squared, and I left it separate. Then I divide by this, and that's going to be Z squared minus 5Z, right? Plus 6. Please take a look at that. Make sure you follow me.
Mm-hmm.
I want you all to take a look and make sure you see. If you multiply both sides by Z squared first, over here you're left with Z squared minus 5Z plus 6, and I'm down to this point. Do you all agree with me?
Mhm.
Mm-hmm.
Work with me on this. And give me a little grace here to finish this problem, all right? Just allow me to stretch this just a tad. So now my YZ is equal to, well, 4Z cubed, right? But I'm going to divide by Z right off the bat. So that means it's 4Z squared here. And then I have what? Z minus 1. What is this factor to? Well, isn't that Z minus 3 and Z minus 2, right?
Yep.
Take a look. People,
hmm
Lydia, you see it?
Why did you divide by Z? Couldn't you just solve?
No, look at the power.
by
This is Z times Z
minus
squared, Z to the third. This would have a Z to the third power too.
And now we can do partial fractions, right?
That's exactly it. Now it's basically over. That's equal to A over Z minus 1 plus B over Z minus 2 plus C over Z minus 3, right? Is equal to this, correct?
Mhm.
With me?
Mm-hmm.
All right. Now, remember that's Y of Z over Z though. After I get these coefficients, I still have to multiply by Z, correct?
Right.
How do I get A?
Oh, that's a 3.
Well, what would it be?
Just
The
cover
pole
up.
is Z equal 1, right? Right?
Yep.
So I cover up the Z minus 1, and I evaluate the remainder, whatever's uncovered, at Z equals 1. When Z equals 1, I have 4 on top, right?
Mm-hmm.
Mm-hmm.
Then I have minus 2 minus 1, which is 2. 4 over...
But I thought that would be 0. It'd be 1 minus 1.
I don't...
Oh, no, sorry. Sorry.
You're covering up Z minus 1, right? Are you with me?
Yes.
Let Z equal to 1. you have 4 times 1 squared is 4 on top. Then you have minus 2 minus 1. Minus 2 times minus 1 is 2. 4 over 2 is 2. Agree? Somebody give me b minus 2. Class? Cover up z minus 2, right? Let z be equal to 2. So I have 4 times 4 is 16, right?
Be negative
Negative 16.
Mm-hmm.
So I have 16 divided by what? It's going to be 2 minus 1 is 1. 2 minus 3 is minus 1, so it's minus 16, correct?
Mm-hmm.
And the last one, z minus 3. Anyone?
It's 3 squared. 4
18.
squared.
I agree with 18.
I think it
Yeah,
is
36. 36 divided by 2.
18.
18.
All right, now to finish this problem up, remember that's y of z over z, right? So we multiply by z, right? And now we have y of z. Agree?
Yep.
Now, if that's y of z, what is y of n? First
The
one,
first one is 2.
Is 2.
just u of n, right? 1 to the n is 1.
Mhm.
What's the next one?
It's
Is it-
16. 2 to the n u of n.
And the last one? I know it's 18.
3 to the n u of n.
Yeah.
What bothers you about that? Something should irritate you. Well, we see it right here with the poles, right? The poles are outside the 1 circle, right? They're at values.
Yeah.
Remember I told you that any pole outside magnitude of z equal 1, anything at z equals 1.5, 2, that's an unstable system. Look at the response. Isn't it unstable? 2 to the n as n gets large is going to infinity, so is 3 to the n. It's an unstable output. This is an output that would last to a point, but then the system would go unstable. Whatever this is describing, it could be describing anything from pressure to velocity, but whatever it is describing is going to go into a failure mode at some point. Got me on that?
Mhm.
I'm over by about 4 minutes. I'm going to give you some more homework, and some people, I'm giving you homework I put up already. Sometime this afternoon, I'm probably going to ask you for something to be handed in, and it'll either be Monday or Wednesday, but I'll be very clear about that, okay?
Okay.
And if you have questions, please let me know.
Okay.
Yes, sir.
Does this make sense to everybody?
Mostly, yeah.
Yeah.
Any questions at all about the inverse Z transform? Because it's just the same as the Laplace in terms of doing a pole expansion, right? And then evaluating the coefficients of the poles and knowing the transform pairs. Now, there's a lot of things that can get really complicated. If I have something where the transform pair would be something like a 1/2 to the n cosine of pi over 6n plus pi over 2, that kind of stuff I stay away from. I don't try to drive you nuts with that. But if I fed that in to a system, if that was the input to a system, and you had a difference equation, then the output to that system is probably doable. But just going from a difference equation, that would be a pretty complicated difference equation to get a decaying or something with an exponential decay times a cosine. If it's just a cosine, we're going to see that that's very doable. You'll see that. But I'm going to ask you to do some of these problems and also the frequency response. But I'll tell you right now, I'm going to ask you to do 21, 22, 23, I think you'll be doing, and I've already put a bunch of them up there if you look in the next upcoming homework. It should be up there on OneNote if you take a look. All right, let me stop sharing that screen. And any last questions for the good of the group or comments?
I am still a little bit confused of what you would do for something like z to the power of n, z minus 1.
Yeah, all right. I mean, go back to casting. Wait, is my screen being shared over here?
Yes.
Yeah, it is.
All right, so you're asking, I didn't answer that question. If you had something like z cubed and it's z squared minus 2 or something like that.
Right.
In the book, this is a shift the other way. It would be plus 1. Let me just show you the property. If you can turn to page 370. And look at property 4, 1, and then 4a.
Okay, I see him.
Instead of being divided, now you're multiplying. So this is really what? It's really z right here times z squared. Matter of fact, let's not even make it z squared. Let me just do it this way. Suppose you have z cubed or z squared over z minus 2. Well, that's really z times z over z minus 2, correct?
Yes.
Okay. Now, I know z over z minus 2 corresponds to 2 to the n u of n, right?
Mm-hmm.
Yes.
When you multiply by z here, you effectively make this 2 to the n plus, no, let me actually do the property here. In the property, he has, if you have, assuming x of n goes to x of z, then x of, and the way he's going to say it is going to be x of n plus 1 u of n. He does this first, is really going to be z times x of z here minus z, and it would be x of 0. Now remember before what happened here, you would have, if it was an n minus 1, u of n minus 1, it would just simply be x of z over z. This is a form of an initial condition.
Okay.
And that's what you have to be aware of. So you would have to take this into account over here. I mean, that would be that. Can I answer this more thoroughly on Monday?
Okay.
Because I'm going to do problems that have that, but I want the whole class to be there for this one.
Okay.
I just have one question, Dr. Baginski. Like, I know you say you're gonna go over it further, but so, like, the more n you have, like, the more times you multiply by z, the more times you have to add whatever the initial condition is, right?
Yeah, and well, the possible initial conditions, it could be minus 2, minus 3. So here, when you have x of n plus 1 u of n, you realize that u of n kills any values for less than 0.
Yes.
Right? But it does shift the the values of x of n by 1. Mm-hmm. So really at u of 0, it's really x of 1 now. Follow me?
Mm-hmm.
It's shifted. Well, that would entail, it would be the z transform. If you had x of z times u of n go to, x of n, u of n, if it went to x of z, then if you have x of n plus 1, it would be z times x of z, the original x of z times z, minus z times x of 0. So now the initial condition that doesn't show up here would be added over here or subtracted.
Mm-hmm.
All right. Now, if it was, for instance, 2, then it would be z squared x of z, and then it would be times z of x of, well, it would be this thing, so it would be
so x of 0 plus x of 1.
Well, it would be z times x of 1, and then z squared, or I'm sorry, z times x of 1 plus z, well, wait a second. I got to think about
z
this.
Times x of 0 plus z times x of 1.
I mean, you'd literally just do this relationship. So if m is 2, right? you go from I equals 0 to 1, and you would have, when I is equal to, it would be Z of 2 times the quantity. Then it would be X of 0, Z of 0, just X of 0 plus X of 1 divided by Z plus X, just X of 1 divided by Z times Z squared. So it's just times Z. But if this algorithm will work for you.
Okay.
If you use it. And I'll do some examples of that. I want to make sure you take note. None of these things, all right, has a U of n plus anything in them. All right, but they do allow for the initial conditions to be put in at x is equal to -1, x equals -2. And those are just the initial conditions. We don't go back to an n equal minus infinity ever.
Okay.
That's it. And I'm going to
Sounds
talk
good.
about that on Monday, but I'm trying to focus on some of the major things. Got to tell you one other thing. A couple of these relationships, time scaling, time reversal, and the summation property are important. I'm going to do some of this on Monday. We know about this one because we talked about it, but the multiplying by n is minus z times derivative of x with respect to z. But some of this stuff, until you see it and really work with it, you're going to be very uncertain about how it really changes things. Okay.
Okay.
Any other questions?
I had a general question, I guess, about the grades that were sent out. I noticed like quiz 6 was missing, and it looked like the MATLAB was in place of quiz 6.
I'd have to look at yours specifically. All the grades are in there. Some people didn't do a MATLAB assignment, and some people missed quizzes. But I mean, Lydia, you have all the grades, right?
I haven't checked too thoroughly. Let me take a look at it right now.
Nicholas?
I've got a MATLAB 1 instead of a quiz 6 as well.
Oh,
So-
that's
but it's all there, it looks like.
the numbers of the quizzes don't correspond. I think there was like a quiz we didn't take that I had put in there, and so if you think the quiz 1 on your paper is reflected by the actual value, it may be shifted by
that's
1.
right. Yeah.
Okay, and
Let me take a look at my quizzes.
and for the MATLAB, was that still optional, or is that going to count as a quiz grade now?
No, I use that as an additional grade when I collected that. That was
What
the
was it?
assignment everybody
Quiz
turned in.
6?
It
Oh,
was
right, that was
just before we were on the remote desktop business.
quiz 6.
This
quiz
I just thought I had
7.
recalled you saying in class that it was going to be like a bonus.
It
a
is,
bonus
but
quiz.
effectively, it's going in as to replace your lowest quiz grade. Remember, I dropped the lowest quiz, so effectively, if you turn it in, everybody got a 10 that did it.
Okay.
We only went up to quiz 8, right? And then there was a MATLAB question as well.
Assignment, yeah.
Yeah, MATLAB assignment, and I think it got